Welcome to Unstuck. Today, climbing stairs, the problem everyone uses to learn dynamic programming. We'll write the obvious recursive solution, watch it explode into 300 million function calls, then fix it with 3 lines of DP. Beginner friendly from scratch in Rust. The problem, you're climbing a staircase with n steps, and each move you take either 1 step or 2. How many distinct ways are there to reach the top? Sounds like a puzzle. It's actually a doorway into the most important technique in interviews. If dynamic programming has ever felt like magic, this video is for you, and a like really helps. Let's find the button first. Here's the key insight. If your Zetterscher standing on step n, your last move came from either step n-1 or step n-2. There's no other way in. So the number of ways to reach n is just the ways to reach n-1 plus the ways to reach n-2. One line, that's the entire problem. Check it by hand. 1 step, 1 way, 2 steps, 1, or a double, 2 ways. 3 steps, 2 plus 1 is 3. 4 steps, 3 plus 2 is 5. 1, 2, 3, 5, that's the Fibonacci sequence in disguise. So, the obvious code writes the formula literally. A recursive function that calls itself for n-1 and n-2 with a base case at the bottom. Let's do exactly that and count how many times the function gets called. Here it is in Rust. If n is 0 or 1, there's 1 way. Otherwise, ways of n-1 plus ways of n-2. We pass a counter to tally every single call, looks perfect, run it for n equals 40. The answer is 165 million ways. But look at the cost. 331 million function calls in nearly half a second over one number. Why? Ways of 40 calls, ways of 39 and 38, but ways of 39 calls, ways of 38 again. The same subproblems get recomputed millions of times. Every step you add roughly doubles the work. That's O of 2 to the n. At n equals 50, this would take minutes. At 80, longer than your lifetime. The fix is the essence of dynamic programming. When subproblems overlap, compute each one exactly once. Instead of starting at 40 and recursing down, start at 1 and build up. And since the formula only ever looks back 2 steps, we only need to remember the last 2 values. Here's the bottom-up version. Prev and cur start at 1 and 1. Each loop step computes next as their sum, then shifts the window forward. No recursion, no memory of anything but 2 numbers. Running, same 165 million ways, 39 loop steps and 4 microseconds. 331 million calls down to 39. 331,160,000 calls versus 39 steps, about 100,000 times faster for the same answer. That's what computing each subproblem once buys you. There's also a middle option. Keep the recursion but add a cache, so each value is looked up instead of recomputed. That's Memoization. Top-down DP, same O of n. For this problem, the bottom-up loop is simpler and uses constant memory. Trace n equals 5. Start with 1 and 1, 2, 3, 5, 8, 4 loop steps, and ways of 5 is 8. You can verify that by hand, it checks out. Common mistakes, getting the base cases wrong. There's exactly 1 way to stand still, so ways of 0 is 1, not 0. Submitting the naive recursion and getting time limit exceeded. And on big N, the numbers grow fast, so use a 64-bit integer. And the real lesson, whenever a problem breaks into overlapping subproblems, that's dynamic programming knocking. House robber, coin challenge with the distance, they all start exactly like this staircase. Recap, the ways to reach step n are the ways to n-1 plus the ways to n-2. Naive recursion recomputes and explodes. Bottom-up DP with 2 variables does it in linear time and constant space. That's climbing stairs. And your first real DP. Quick one. If these help you, the wallet's on screen and there's a Ko-fi link in the description. Every tip funds the next one. The full Rust code is in the description. If this helped, hit like and subscribe on the new coding challenge every day. See you in the next one.